Okay, greetings everyone. This is the Flat Level Show. It's going to be the first presentation of many presentations. Each one, with this one starting, I will take one proof for the flat earth, break it down in specific detail, best as possible, in a digestible slideshow. This is all my original work that I took time out to do the research and put together. Most of this information is not really disclosed because obviously they don't want us to know, but the proof is there to see. And that's what I'll be showing in my videos. Not many people are doing this, so if you can show support, please do. I love science, and I believe anyone can look into this and understand what is going on here. You don't need a degree or anything to study to understand how the ground you stand on works. I will bring as much actual scientific evidence as I can find and put into one presentation and prove that the Earth is not, in fact, a spinning globe. Yes, scientific evidence. There are many proofs and much evidence to support this. That's why I have to make many presentations because it can take 1 hour, or it can't take 1 hour or one proof or one presentation to get all this information out for people to see it. So without further ado, let's start. This is the first one. It's called Horizon. All right, I'm supposed to start with this one. It's the first slide, Horizon. All right, this is gonna be first one. This is the first picture. As you can see, from high up in the sky, the horizon is flat, and it's called sea level because it's level everywhere. Water always lays flat, and also horizon always at eye level is only possible on a flat plane. So the fact that it's level, that can only be possible on a flat plane. On a globe, if we were on a globe, the higher you get, like where it says sky level or earth level, you would start to see that curve more, and we don't see that at all unless the image or video is CGI. But from actual photographs that we have, which I will show later on, that the higher you go up, the horizon is always flat, and it's always at your eye level. It's never below you or above you. So next one. This is the official definition, meaning of horizon. Definition is the parent line that separates the sky and the ground that you see. It's where the top meets the bottom, top sky meets the ground. It's the limit of a person's mental perception. So you can't see beyond the horizon. I mean, that's pretty much true. It's different everywhere based on you and your line of vision. So if you're, in a forest or something, obviously you won't be able to see too far ahead of you. If you are on a beach, then you can see for miles and miles, right? It's actually not apparent, but it's physically there. So they say it's apparent. They say the horizon is a parent line, and that what you're seeing is actually, below. It's a certain amount of degrees below your eye level or the horizon. But they're really what you see is what it is. So if you see the horizon, then that's where that's just as far as your perception can see, because they tell us that there's 5 horizons on a ball Earth, on a globe, and I'll get into that more. So, but like I said, there's only one horizon. You can only see one horizon, and depends on where you are. There is no 5 different horizons where different angles. but let me get into the next one. So here it is. There are three basic elements needed to construct a linear perspective drawing. So there's three basic elements to determine the horizon. Oh, sorry. So you got the horizon lines, like what I said, sea level, sky level. You got the vanishing point, which is in the middle, because if you look over to the sides, if you look to the sides, it's longer than if you were than from where you're standing to the vanishing point, if that makes sense. So, and if you can look in these pictures here, they all show everything, it goes into one point. You know, your eyes automatically make this, makes this vanishing point on the horizon line. So, so yeah, everything that you look at, if you're looking straight out on a beach or flat, this piece of land, everything is gonna, everything that you see is gonna tunnel in into one small point, and that whole, and it's gonna be the whole horizon line. And like I said, if you look on the left and the right side of this horizon line, it's longer than you looking straight up at the vanishing point. From where you're standing to the vanishing point is shorter than the horizon line from east to west. And like I said, that's only possible on a flat plane. On a ball, it will be even all around. All right, the horizon line, the true horizon line, they say, can mostly be seen at the ocean or wide area of land. Right. Otherwise, horizon can be obstructed by terrain, trees, and buildings. That's what I just said. See also, the horizon surrounds you at all times. Okay, mainstream science says the true horizon line is below the observer and below the sea level. That's what I was trying to say before. So when you're like, they tell us that if you're out on the beach or whatever, or a wide area of land and you can see the horizon clearly, they're saying that that horizon is not actually at your eye level. They're saying that what you're seeing is just the apparent horizon, and the actual horizon is actually below, somewhat below, because the globe curves, right, supposedly. And so they even say that the light bends over that curve, which is completely untrue. But I'm not going to get into that. That's a whole nother presentation. So yeah, mainstream science says the true horizon line is below the observer. According to National Geographic, there are 5 horizons, 2 celestial, and 3 are Earth sky horizons. So yeah, to me, like, it just makes no sense. How do you have 5 horizons? Just makes no sense. I'm gonna try to explain that more if I can. But here's the next slide. Horizon on the globe debunked. What they always demonstrate the curvature and horizon on paper, on 2D paper, which doesn't match to reality, because reality is 3D. So how can you show us 2D demonstrations of curvature and horizon when you can't even do that in real life, because we're 3D. They theorize what they think and apply it to a paper or computer, which makes no sense because that's not the real world. Like I said, we can simply see too far. They even admit this, officially saying an observer on the ground can see less farther away than someone at the top of a tower. So yeah, so like, if you're standing on the ground, like, you can only see too far out to the horizon. You can only see so far out to the horizon. Let's say, it's like, I believe it's like 3 miles, where it's like your actual limit where you can see, depending on where you are. But if you're on a beach and it's wide open, or if you're on a a piece of land that's just wide open and, you know, level. Um, they're saying like if you're standing on the ground, you know, you can only see so far on that plane or that beach, which is probably, I want to say 3 miles. But if you go up on a building, right, and you go, you know, same spot where that person is standing on the ground, you go up in a building and you can see even farther. So that kind of proves right there that, you know, what you're seeing is not, it's not the curvature. That horizon line is not the curvature. It's not the end. Because like I just said, if you go up on a building and you look further out, you'll see more land. So, and it's more, you know, level. So I'll try to explain that more in the next slide. Here we go. So here we go. This is what they explain to us, and just doesn't make any sense. So here you have three horizons. Like I said, three, when you're standing on the ground, they tell us that there's three horizons. And then they tell us there's two celestial horizons, which is if you're in the sky or something. I don't quite get that. But anyway, so if a person is standing here on the earth, which is, this figure is way too tall on this model ball globe. But anyway, the true horizon, if you see, he's looking straight. He's looking down, first of all, which makes no sense. And then, yeah, this just makes completely no sense, because look at this whole curve right here. How are you not seeing this curve right here? You know, and what about, you know, so they say the true horizon is what you're seeing, and then it stops halfway, and then it keeps going into space. So like technically you're supposed to be looking into space then. This just makes no sense. And then you have the visible horizon, which, like I said, is if you're looking straight out, you know, as far as you can see, probably 3 miles or so, that's the horizon. But if you can see, he's looking at the top of this tree, which I know for sure no one is taller than a tree like this. And then to be looking over it straight out into space just makes no sense. And then once again, there's a third one, astronomical horizon, which is completely BS, because he's just looking into space, basically. How is that a horizon if you're just looking up into space? It's not even looking up, he's looking straight. So this, and I got this off of like Wikipedia. So they're passing this off as actual proof, which is not. This is completely false. So next one. All right, here we're gonna get into a couple pictures of some flattest places on Earth. Basically everywhere is flat, but these places that if you go there, you can actually, I mean, you can see how big and flat and wide these places are. This is don't know how to pronounce that, but this is Germany. This is in Germany. It's called the Mud Flats. As you can see, it's completely leveled off. Some people walking there. All this is mud. Apparently, this is like a muddy area. And yeah, as you can see, it's pretty much leveled out as far as you can see. Next one, Salar di Uyuni. I forgot where this is at, but if you can see clearly, this is all leveled out. Danakil Desert. Again, I forgot where this was, but this is like one of the like a top flattest places in the world. Everglades, Florida, pretty big place. And it's flat for miles and miles and miles. The Maldives. I don't have a picture there, I guess, but next one. See how we're doing with time wise. All right. All right, the appearance. The horizon is a horizontal plane through the eyes of the observer. The horizon is a plane that is in the center when you look straight, not at the ground like most people think. So yeah, so like I said, the I forgot which slide it was. Yeah, the vanishing point. Yeah, the horizon is yeah, like basically like if you're standing up straight on anywhere, the horizon is not at your feet. The horizon is at the end of as far as you can see. Basically, I can't find the word for it, but if you're looking straight out, you know, it's that line, basically that horizon line, sea level. Next one should blow the lid off of everyone, especially the scientists of the world. Okay, according to science and even artwork, the curvature of Earth is disregarded and the horizon is considered the theoretical line. And then they go on to say that there's a geometrical horizon and true horizon and apparent horizon. That's what I explained already before. There's three, horizons that you can see, which is not true. But the first slide explained how you can only see the true horizon with no obstructions like ocean or hill. So technically, there is no geometrical horizon, and I believe I'm proven right because they say that you cannot tell the difference. So yeah, let me go back. So they say the curvature of Earth is disregarded. Like if they're doing like work or experiments or studies or anything like that, they disregard the curvature of Earth. Like if they're saying like if they're studying like let's say one country to another country, obviously there's going to be curvature in between, right? But they always disregard it. They never include the curvature of whatever they're doing. So that's number one. And then they say the horizon is considered the theoretical line. So they don't even call it the actual horizon. Like they say that, what you're seeing is not actually there. They're basically telling us that we're not seeing correctly and that we're not seeing the right thing and that our eyes are, playing tricks or whatever, which is not true because, I mean, in other cases, in some cases, there are things like that where it's like like I call them like conundrums or something, but I'm not going to get into that. But either way, they tell us that what we're seeing is not there. Like I said before, when you're looking straight out at a beach or anywhere where you can see as far as you can see, you know, where you should see the convergence lines and the horizon line. They're telling us that that's not actually there. Like for example, for boats over the curvature, right? When you're looking at a boat on the water going away from you, they tell us that is going over the curve and that the hull is up, right? The ship hull is up or something like that, meaning that it's going over the curve. So I mean, like that's what it looks like, right? When we see that with your naked eye, it looks like that. But if you always pull up a binoculars or telescope, you'll see that, you know, you can probably see further, and that boat is probably still going to be there for some point. But then it will eventually go away because you just can't see as far. You got atmospheric conditions, you got clouds, you got refraction, you have all these things, which I'm going to get into another video. But as far as the horizon goes, like I said, but when you're looking out at a beach, that horizon line, that that is actually the I gotta mute up. Be right back. Sorry. All right, I'm back. So yeah, just saying, yeah, the geometrical horizon and the true horizon, apparent horizon. So the apparent horizon is, like I said, what they say is what you're looking at when you're looking straight out, and you see that curvature line. You know, you see the vanishing point, obviously, and then you see the convergence line, the horizon. They're saying that that's not actually there. You're not actually seeing that. There is a true horizon. There is a, I mean, obviously, even, for anybody right now, there is a horizon, but um, you can only see so far either way, right? You can't see China from India, it just doesn't work that way. So then they also say, so they say it is a true horizon, which is supposed to be there, but you just can't see it, which is the apparent horizon, which is, what you're looking at. So it just makes no sense. They just contradict themselves. And then the geometrical horizon is, I'm not too sure. I got to look that one up again. Let me see. I don't think I can find it right now, but I'll come back to that maybe. See, it says here, due to atmospheric refraction, the distance to the visible horizon is further than the distance based on a simple geometric calculation. What? The atmospheric refraction, due to atmospheric refraction, the distance to the visible horizon is further than the distance based on the, yeah. I mean, yeah, that is true because, like I said, for anybody, if you're looking at a boat on the water or a ship and it starts to go away, yeah, it's going to start to disappear, of course, whether it's on a globe or not, that's what's going to happen. But they tell us that once that disappears, on even on a nice day where it's not too much clouds or refraction, it's still going to disappear, right? But you can bring, like I said, bring a binoculars, a telescope, and you'll be able to bring that back up depending on how far it is. You know, like I said, if it goes too far, then obviously is you're not going to see it. But as far as with your naked eye, that's how they get us, because with your naked eye, you start to see that disappear quicker because you can only see so far. There is a horizon, there is a vanishing point, which is, like I said, about 3 miles or so. So after that, you won't be able to see anything. You just see sky and the horizon line and, water. But if you get a binoculars or telescope or anything, you could bring it back up. So that's what they tell us, the apparent and true, or yeah, apparent horizon, geometric. Um, I have to look it up. I don't know why I can't. I forget what that geometric one is, but the apparent um, and the true horizon, that's what I just explained. So yeah, so like I said here, right here, but the first slide explains how you can only see the true horizon with no obstructions like ocean or hill. Um, yeah, which is that's the only horizon that there is, basically, because there's only one. Although you can't see further, that doesn't mean that there's another horizon there. Um, to see no obstructions like oceans or hills. So technically, there is no geometrical horizon. That's basically what I'm trying to say. And I believe I'm proven right because they even say that you cannot tell the difference. Keywords they use: assuming, featureless sphere, huh? True horizon, geometrical horizon, apparent horizon. Yeah, it makes no sense. There really is only one horizon. Here's some more mumbo jumbo math they try to give us with the curvature. So basically, like, see this boat here. If you're on this this boat, this ship, and you're traveling over this apparent supposedly curvature. See, they showed this point here in the middle where it's flat, but why is it flat here and it's not flat here or here or here? You know what I'm saying? Because on a ball, on a globe, it's even all around. This circle is even. So it can't really be flat, it's curved. So, and then if you're on this ship, looking straight out, right? If you're looking straight, you're going to be looking into just the sky. You're not even going to be looking at the ground. I mean, a little bit, you could, if you look down here, but if you're looking straight on this ship, on this angle, and you're looking straight, you're going to look at just the sky, which we never see that. We always see the ground first, or, if you're looking straight, you see the horizon where the sky meets the ground, and then you can see the ground and you can see the sky. I mean, if I'm thinking, if I'm on this boat, this ship right here, and I'm looking straight, and I don't look down or up, I'm looking straight out at the sky and I don't see the ground at all. You're supposed to, I mean, if you're looking straight, technically you should see the ground. I mean, that's what the horizon is where the ground meets the sky. So, and you see that at pretty much all times, unless, like I said, there's obstructions like trees and hills and mountains, whatever. But this, this is on a boat, on a ship, on the ocean. So completely false. Next one. Here's some more fake math demonstrations. Yeah, this one right here on the left makes no sense because right away I can tell you that, first of all, how can this be possible? Like, okay, if you're standing right here in the middle of this circle, basically we do have a dome around us, like it's not a real dome, but when you're standing up outside, anywhere you are, doesn't matter. 360 around you is your observable, your observable area. I can't really explain that much, but yeah, I thought, like, at first I thought like this was supposed to be like a globe, I guess. So then I thought like these lines here, if we're on the outside of the globe, right, and we're staying on these lines, it just this wouldn't make sense because this diagram is based off of the middle, but as you can see, it's flat, like, it's all flat here. There's no curve. So yeah, they just make this up so they can try to, explain away the curvature and horizon. So next one, curvature and horizon. They say that horizon appears slightly convex, right? They even have photographs. It's not otherwise. It would be curvizing. They claim curvature can be seen at 6 miles up, the same as an airplane. I've never seen curve though. However, because of light refraction in clouds, you cannot see it, which is more lies. So yeah, they say the horizon is slightly convex, which doesn't make any sense. But I did see a video a while back where they show like this camera going up to the sky, up in the air, and as it was going up or coming down, I'm not sure, it did show the convex, but I believe that was only because of the camera. So, but yeah, I'm not too sure about that. But either way, I mean, if it's flat, then there's no way it can be, convexed or curved or anything. Obviously, they call it horizon, not curvizing, or they call it sea level, not sea curve. They claim curvature can be seen at 6 miles up, which I've been on an airplane before, and it was all, if you're on an airplane and you're looking down, sometimes Yeah, you can only see like let's say you're flying over the states, you know, United States, and you're passing over like, you know, one state, uh, you know, whatever. If you can see, if you can see, like if you look down and you can imagine how many miles it is that you can see from one point, you know, from like the back of the plane to the front of the plane. If you look down, imagine how many miles that is that you're looking at. You know, there's probably hundreds and hundreds, if not thousands of miles straight if you're looking straight down on the airplane, you know, at land. So, and I've done that before. So right there, I mean, they tell us that the curve is, I think, what is it? Um, Man, I can't remember it. 8 inches per square mile. 8 inches per square mile. So, I mean, if you do the math, 8 inches and then times, say, 100 miles, there should be a bunch of curvature there. So, and when you're on a plane, like I said, you're looking at least 100 miles, if not more, at a time. Because remember, a plane travels at, you know, high speeds and whatever. So even though, you know, obviously the Earth is big, so you're not going to be, you know, uh, speeding through. Like, I mean, you're not going to be like, you know, on a jet or anything, but still, you're going pretty fast on a plane. And when you look down, like I said, you can see for miles, if not hundreds of miles, and there's no curvature at all. So, all right, flat Earth facts, no globe. All right, this is what this is actually from National Geographic. What they tell us. I'm gonna break it down a little bit, and then this is gonna be almost the end here. Most people continue to believe the Earth was flat into the late Middle Ages. The horizon was interpreted as the sharp edge of the Earth, although no one has ever reached it. The horizon also helped prove that the Earth was a sphere as early as 330 BCE. The Greek philosopher Aristotle noticed that certain constellations in the southern sky rose higher from the horizon as he traveled south. This can only be possible if the Earth was round. That makes no sense at all. Certain constellations in the southern sky rose higher from the horizon as he traveled south. No, all the stars move at the same time, the same pace. Depends on the time of year. If you're traveling whatever and you know in the winter that and you're looking up at the stars, they're not going to be the same stars as the summertime. If you're in the summertime and you're traveling, the stars are going to be different, you know, regardless. So next one, continue. So yeah, so 330 330 BCE, they started to believe the Earth was a sphere, right? Supposedly, technically. But it wasn't until 1500 AD is when people stopped believing that the Earth was flat. That was only 500 years ago. Even so, they based everything off observation, which we do observe flat. Then, when modern technology came, is when we started to say it's a globe. But modern technology is when? I would guess around 1900. But I believe they had it way before that, even 1,000 years ago. Um, but even so, early 1900s, we weren't even going to space yet, but they were calling it a globe since 1500 and even 330 BCE. And even, you know, 1900s, 1910, 1920, 1930s, 1940s. So, and also between 330 BCE and 1500, well, it's actually over 1,000 years, but yeah, it's about 1,000. It's over 1,000 years, but still. So anyway, this is what they tell us, and I'll get more into it in the next slideshow presentation. But this is going to be it for this one. Let me just get to my notes real quick. So yeah, this is the end. Starting to get into other topics about this. See, I love this so much. I can go on and on about this, but I want to keep it short and simple for people to watch and to digest. I find more information. If I find more information, or if anyone has any questions, let me know. Email me or whatever. Leave a comment. I can make a part two, but I'm just gonna be working on the next presentation now, being that this one is done. Took me about a week, but this is my first one, and obviously the slideshow is not the greatest. I'm just put it together to try to get this out, but hopefully I can get better at the whole just editing and whatever. But anyway, this concludes my presentation. My first one hopefully came out all right, and yes, thank you all. Much love. Keep it flat.